So anyhow, this is really a status that Barry put together for the Dayton Hamvention, and we've done a little bit of updating. But as you all know, AMSAT is an all-volunteer organization.
Can we just fix your mic so that we get the modulation level fixed? Sorry, keep going. Keep going. Thank you.
Anyhow, which is not any different than any of the other AMSATs. We're all just a bunch of volunteers, and we have one employee at our organization. And so anyhow, we've been around since 1969, and so that puts us up to 40 years, and we want to keep going with this thing. So we've been doing a lot of soul searching on how to make this work, and we've started to emphasize our mission statement, which is we design and build and operate experimental satellites, and we've really started emphasizing the space education side of it, which I can see that AMSAT-UK is also doing an AMSAT-DL. So in fact, all the AMSATs are pushing education now. We have a very strong partnership with NASA in the ARIS, the human spaceflight part of NASA, and we're really trying to push technical innovation, so that which to me is one of my more favorite parts of it. We are trying to deploy satellites just like all the AMSATs are doing, and trying to keep ham radio in space. We participate with all these human space missions. We first started doing that with Owen Garriott in 1983, which was the first manned ham radio in space, and that predated, of course, the Mir even. We're supporting all these LEO satellites that are being put together, and doing our best to promote those and promote the ham radio on those. This is a picture of the latest ham station in orbit. As you can see, I got this just recently. It's one of the few pictures that shows the shuttle on there, which I was very proud of seeing that. This is actually, we have ham stations on board the Russian module and on the Columbus module now. This is the first ham radio system that went up for ISS. You can see these are the two. One of these is a VHF radio, and the other one is a UHF radio. Right now, the UHF radio is connected. This packet module is connected. They're using all these components in the Columbus module. It's amazing. That was the first ham radio taken up for ISS, and went up there, and it was actually installed before they permanently had people on board. So this is Mike Bowl operating the ham station in the service module, and this is the Nespoli operating it in the Columbus module. ARIS was established in 1996 as a result of the Mir operations and the shuttle amateur radio experiment operations, which I worked on from the beginning with that. My wife's tired of me working on ham radio, so I keep telling her, well, maybe next year, but we keep going. We've tried to tailor our work to support this STEM push for everything, and we're trying to do as much as we can to tie all the things we're doing to the space education. To date, they've made over 600 contacts around the world with the shuttle or the ham radio on ISS. Most of them are directs A lot of them are done through standard stations that we have around the world where they connect up by telephone. The telebridge thing is quite reliable, so we've had somewhere like almost 100% success, but not exactly, because there are failures from time to time. But the ham radio equipment has been working very well. We are now working to promote this education, and NASA is getting much more involved in selecting the schools. In the past, when we first started, people would just send me an email, say, hey, I want to do this, and I would set it all up, and we would do that. And that was when I was working for NASA. And then I'd say, well, I shouldn't be doing that. I shouldn't be selecting schools. So we turned that over to ARRL, and now it's really done in conjunction with NASA. One of the things we get out of it is free launches to ISS, and that's been through our Russian partners in the past. And we don't know whether that's going to continue or not, but we think it will. But we're also going to look for other ways of getting to ISS. There's the European cargo, and also the Japanese have the capability of taking up cargo for us. So that's why we're pushing to put equipment in the Columbus module. The first launch opportunity we've had since SUITSAT-1 is ARISAT, and we made a commitment to RSC Energia to do an ARISAT, or to do SUITSAT-2, and we spent a lot of time working on that. And then the surplus suit that was on board had to be disposed of because they were going to a 6-man crew or 6-person crew, and so they just didn't have the space left over. So then we continued with our commitment to put this together, and we built a space frame to put all the components in, and did some re-engineering, made some parts of it simpler. But it actually was a blessing in disguise, we think, because first of all, we still hadn't figured out how to put these solar panels on the suit. That was just a very complex thing, and to make them so that they would actually get power at all orientations, we were having trouble figuring that out, and so were the Russians. So in that respect, it's been a good thing. It also let us do some proof of concept work that we hadn't done before. And I do have another presentation on ARISAT, which I'll go over what the differences are and some of the things we started and tried out with this that hasn't been done on ham satellites in the past. So we also put together a pretty big team to make this happen, and those folks are now pushing or working hard on the AMSAT Fox, which we'll talk a little bit about. It's been certainly a great learning experience for all of us. In order to build the ARISAT, we had to configure this to handle the solar panels that were donated to us from NASA. They really set the shape and size of this thing. We put 4 of them around the outside, and 1 on the top and 1 on the bottom, and the antennas and all that. And that really defined the configuration. It's approximately 2 foot by 2 foot by 1 foot. And you'll see that in the pictures. Some of the other things we pioneered with that is a maximum power point tracker for each solar panel. And we use a 28-volt bus, which is the battery voltage. And we let the bus go up and down. It's not a regulated bus, it's a current-fed bus, which is a different way of building satellites. Most ham satellites use a BCR, and they very carefully have to adjust this BCR and all this. But the way ours is done on AMSAT, you don't have to do that. You just feed the current, whatever current you can get out of the solar panel, maximum power point converters, you feed it into the battery, and you just limit the voltage so that when it gets above a certain charge voltage, it tells the panel converters to shut down. And so it's a whole new thing. We also have the solar panels attached by Velcro, which is a totally new way of doing it, and it works great. Let me tell you, that's the way to go. I would recommend that on any satellite because you could just open it up, work on it, close it back up. You don't have the thermal stresses either. So even on a big satellite, that really works. So anyhow, I'll go over that more when I get onto the AMSAT presentation. One of the things that's happening with us is NASA is pushing very hard to, they want to regulate how the U.S. School contacts and schools are selected. And the way they're doing it now is that there's an open period for making proposals, sending them into NASA. That period just closed, as a matter of fact, for this year, and they sent out something like 15,000 notices to various schools around the country, and there's been over 100 proposals received, and out of that will be chosen all the contacts for the U.S. side for the coming year. So it's a totally different thing, and the proposals we're getting are much more elaborate, and because they put a lot more conditions on them. You have to do this, you have to do that. More publicity, more schools, activities involved with the contact. That does not apply to contacts for outside the U.S., but and those are all done by the coordinators in the various countries. So it's a little different, but it certainly will improve, I think, the impact of our school contacts. So anyhow, that, as you can see, this thing is closed already for this year. And so instead of people giving an application and waiting 2 or 3 years for them to be chosen, they'll be on that year, and they'll know that they're not. They'll know that they're chosen, and they'll also know that they're not chosen, those that are not. So this process, of course, reflects the NASA priorities of education, and they're really pushing that hard, which I think is a good thing. It's what we really intended in the first place. It becomes more of a, you show us that you can do a meaningful contact, not just bring in your kids and let them talk on the radio. So it's a whole different thing. I'm not going to read all these to you because you can all read as well as I can, I think. Anyhow, this whole new proposal thing is going to make a big difference, we think. The AMSAT-1 is the first of a series. We built actually 5 frames, and we have 3 full satellite put together. We don't have all the solar panels. We have to get those from NASA, but we have 3 complete sets of electronics, and we have enough to. We actually have 4 sets of electronics. One of them is the prototype set, so we wouldn't fly that, but we have these things sitting on the shelf now. And when we shipped AMSAT to Russia, we shipped 2 copies, 2 fully functional copies. The only thing you have to do is move the solar panels over from one to the other. So we had wouldn't be called a hot backup, but we did have a fully functional backup. And it's still in Russia. We hope to get that back. The Russians promised us they would ship it back to us, so we'll see. We do have plans to some preliminary plans to take that and send it to the Japanese have agreed to, tentatively to take it up. So we could probably send that up to the Japanese and have the Americans put it out. We think we'd get a little better control of it, that's for sure. Our amateur radio work on the ISS is, of course, changing and expanding. We have relocated the original ham radio equipment, the Ericsson radio, to the Columbus module, and they've been doing some work on there. They've done some school contacts. Of course, it's like you drive a Cadillac. You don't want to go back and drive an old Ford. So
You have to grow.
yeah, have to grow up. Yeah. The Ericsson's only about 4 or 5. It's only 4 watts on UHF. It's a pretty low level signal, so school contacts are not as good. So they decided, well, we're going to go back over here and use the D700, which is 25 watts. Big difference. So, but we're still planning on other things. The Europeans have been working on a digital ATV system. There's a lot of discussion about how to build that and how it will work, and that's still in the talking stage. Our next project is to build a power supply that can run off the 120 volt DC that will power the Ericsson and a D700. We're talking about moving one of the D700s or sending up another D700 for the Columbus module. And if we do that, then we'll be managing the school contacts and ARIS contacts out of the Columbus module. One of our big activities in the U.S., and we've all heard discussions about this, is the ITAR, International Traffic in Arms. I don't know what these guys were trying to do when they put that into place, but they've done more harm to the American space program than anybody else, I think. It's encouraged everybody else to go out and do their own thing, which I guess in one respect it's good, but it's certainly been a problem for us. In fact, I can't tell you how to build a satellite or I'd be shot, They'd send me to prison when I get back. It's really pretty amazing that they would put this together, but it's really done a lot to encourage all the other countries to build their space programs, because they're so afraid that we're going to help the Chinese. Anyhow, it's just it's crazy. We're trying to do some work to make this thing a little more palatable. One of the requirements for us to be able to give out design information is that it has to have been published, and the way they define that is it has to be published in a paper or in writing, like a magazine or a proceedings or something like that. And we are trying to get them to redefine that to include publishing on the web, because it's a lot cheaper to publish on the web than it is published any other way. And it's just as, in fact, it gets more data out faster. So I don't understand the logic of not including web as publishing. One of the other things that happened recently, as you know, in the U.S. we have a lot of new politicians, let me put it that way, that don't think through what they're doing. And this one guy proposed this H.R. 607, Broadband for First Responders Act of 2011. And what is in that was the reallocation of the 70 centimeter band to this first responders capability. And I think, first of all, he didn't realize that that's really an international agreement. It's not something that we, the U.S. side, can just change. We can change how it's used in the U.S., but we can't change how it's used in the rest of the world. And it would be violating some treaties if they did that. So anyhow, we think we've got him to change his mind. We had a meeting with him, and we sat down and explained to him how AMSAT and ham radio uses that band, and I think he's going to, we think he's going to change that proposal. But it's amazing how these guys can propose something without having consulted with anybody. That's one of the things we have to live with in our system. We're still trying to make sure that the public is aware of that, and we're trying to put political pressure. We don't have much political clout, you know, but we're trying our best. The next project for AMSAT will be the AMSAT Fox. We're still working on that and trying to decide how to do that. Right now the plan is to build. We're trying to push to get one out as soon as possible. It'll be a CubeSat. It'll be one that's dedicated to ham radio activities, not education or science. We may have the capability to put a small science experiment on it, but its function will be a transponder of either FM or a SDX transponder. A little bit about what ARISAT cost us. Barry wanted to tell everybody this. We got a free launch, but it was not a free satellite. It took a lot of work to put it together. As you guys were talking about yesterday, all the work that has to happen, the shock tests and the vibration tests and the thermal tests and all that. But we have spent about $180,000 on that project, including travel. So even a simple system is not cheap. We're focusing on that now, and we're trying to pull in universities to help on that, although my experience has been that it's hard to get much benefit out of that. It costs you just about as much as you get out of it. You do get students, and they do become ham radio operators, so there is a benefit no matter how you look at it. And we're looking at our next development at about $200,000 to put the satellite together and the project together. And well, you can see this here. He says that the combined investment for ARIS and Fox is about $380K. So if you want to make a donation, we have a website, we have PayPal, so you can do that. And we definitely are soliciting. One of the things that's happened really been helpful is the Dayton Amateur Radio Association. They're in the spot of they've been making money every year with their hamvention, and they can't continue to do that in U.S. law. They're not a charitable organization if they make money, so are trying to make it useful, and they have a matching grant thing for AMSAT up to $5,000, which isn't that much, but still it helps. Maybe you could make a solicitation to them for your activities. And what I want to do is now talk a little bit more the details of ARISAT. So all I have to do is figure out how to get out of this one.
Lou, I just have one information. We just heard at 9:33 the ARISAT.
Okay, great.
So we heard the pass, and it was on the 437.
Yeah, that's the
retransmission,
yeah.
but
Let's switch this to the other one.
clearly could hear SSTV packet and voice transmission.
Dayton Forum.
That's the one we're just on. Is that?
Yeah.
Yes.
How do I put that on?
And
Okay. This presentation was put together by Gould, and it has a little more details about ARISAT. Of course, it's as I've said before, it's part of the STEM activities. AMSAT's responsibility was to build, design, and test the satellite. NASA provided some parts. I had an account there where I could send them a spreadsheet of parts I needed, and they bought a lot of the parts for us, which that really helped. RC Energia, their job was to provide the battery and to get the satellite to the ISS and to deploy it. We also, one of our obligations was to fly an experiment for the Russians, and that is incorporated into the satellite. So we had capabilities of flying 4 experiments and lots of room left over on the inside. Microchip, all of you know Microchip and the processors that they sell, and there was a team there at Microchip in Phoenix that designed and built several of the boards, and along with the cooperation and assistance from various AMSAT members. And this satellite probably has more computers in it than, certainly more than any other ham radio satellite. There's, for example, there's one for every solar panel. There's 6 for that. And there's also one for every power regulator. So it's just amazing. This is our solar panel simulator. We use that a lot. It was designed to have a curve just like a solar panel, and it follows it quite well. This was in our lab there in Orlando. This is a picture of ARISAT-1 on the ISS. The Russians made these soft covers, they call them, and it's designed to be to cover the satellite, and when they take it outside, they take those off. You can see the handles. This is the first satellite built with handles, provided by Graham and his company. This is, I guess, the 21st one of those. We had 20 of these built. We couldn't use their normal door handles because they had to be removable from the outside. Door handles are normally have screws in from the backside, so we couldn't have that. So, but anyhow, it's a very nice handle. In fact, the Russians liked this so much because it had exactly the same cross section as their standard handles on the ISS, but its grip is much better because of the recesses in the handles. So it's really a much improved grip on what they have, and I think they're going to start using this idea. So, which is, I wanted to make sure everybody knew about this. What's the name of your company anyhow, Graham? We should put them up as one of the contributors. Anyhow, one of the things we had to do was to put together a safety data pack, and that's another thing that NASA contributed, was the putting together of this document, and that is a very tedious task, believe me. When I worked for NASA, we first started flying ham radios on the shuttle. I had to put together the first 2 or 3 of these packages, and then you need a new one for every flight. And I'm telling you, that is one heck of a job. And we have a person who does that, and she just does a perfect job. Here's a picture of the satellite on the vibration table. We took this over to a company there in Orlando which does industrial vibe testing, and they charged us for this, believe me, but they did give us a discount, and they had a big shaker table there, and we put it on the table, and they spent 2 days trying to get this thing calibrated, because on a shaker table like this, you put sensors on the blocks to make sure that the vibration at the satellite itself is per the specification. And one of the big problems you have is that everything is flexible, including these big blocks like that. There's some flexibility, and especially they all have a resonant frequency, and their blocks or their adapter plates could not handle this satellite. It wasn't that it was too heavy, it's just that its footprint was too big, and they just didn't have the equipment there, and this thing kept ringing, and they'd run a low level vibration on it, and they'd find out that they had resonances, so they couldn't get it exactly right. And so I called some friends at NASA. Good thing I'd worked there. And the NASA Kennedy Space Center folks said, "Oh yeah, we have just exactly what you need." And they had this, we borrowed this from them. It was kind of interesting the way we might even be illegal. They agreed to loan it to us because it was a NASA-related project, and so they took my big Suburban over, which I don't drive very much anymore because of the gas prices, over to the Kennedy Space Center Visitor Center, and the fellow who's making the arrangements drove over from the Cape. They swapped cars. He took my Suburban into KSC, put the big adapter plate on, and drove back to the visitor center, and they swapped cars again. So it worked out just well, because you had this thing, you have to lift with a forklift. You couldn't put it in there without having the proper equipment. So, but the old Suburban, it'll carry anything. You'll see some pictures of it. This is the block diagram of the way the satellite is put together. We have 6 solar panels. Each one of those goes into its own maximum power point converter, and all that is put in the power bus, a 28-volt bus. We have a safety, we call them safety switches. It's actually the control panel up on the top, and they go into a special a special part of the computer that has no processor. It's all done with standard logic, and that's because we don't want to have any crashes that could possibly misdirect the satellite, and that's done with what we'd call glue logic, more or less. That part of it. I do have the schematics, but I'm not going to try to bore you with all that. This is a drawing of it. This is the Kursk Experiment. This is the VHF antenna, the solar panels. Of course, you can see the handles. This was made by the University of Kursk. There's 4 cameras on there. This shows one. The other one is right here, and is looking at this is a chrome-plated brass mirror. We couldn't get glass through the safety panels, and there's a similar setup like this on the bottom of it. These are Lexan covers over the solar panels. They're 1/4 inch thick, and you can remove all those panels by pulling these pit pins. And we went through the whole vibration test. If you can see it back here, with the pit pins installed. So it's all certified for the launch environment. This is an open view without the solar panels. Shows cameras here, the main computer, the maximum power point trackers. and the RF module. This thing is all done very modular, so that if you had a problem with one part of it, you simply took that out and put another one in. They're all interchangeable. So I don't know how many ham satellites have been built like that, but this made this one quite modular and easy to test and easy to switch things around. The panels are put on with Velcro, so you simply peel them off, and you can get in there and work on it and push it back. Worked very well, and it all passed the vibration test. This is a picture of it. This is before we tie down the cables. They're all going all over the place, but for when we prepare it for launch, they're all tied down. This is a mock-up of the Russian battery. It's the same size and similar connector. So here's our production line. You can see here there's 4 space frames, and these are just ordinary fold-up tables that we had in the shack there. This is actually stored equipment. None of this stuff was used for our work. Here's the solar panel covers here. This is my hand, but it's not actually touching this panel, believe me. That panel we protected very, very carefully. But this is the standard. This panel was designed to be used by NASA on their small satellite program, and they built like I don't know, 75 or 100 of these, and their idea was that, you know, we'll just use this standard panel on various satellites, and I think it was used on at least 2 satellites. But now they're considered excess because it's only a 2-layer panels. It's not as efficient as the ones you can build today. Here we are with we had 2 extra panels, and we use those for test purposes. And this is running the satellite here off the sun. Actually, 1 panel will run the satellite. Kursk Experiment is designed to measure the vacuum in the vicinity of the satellite, and the whole idea is to plot the vacuum and how the pressure changes as they start to re-enter. So we take samples once per orbit for this thing. And we had a standard interface for experiments, which is still going to be there for future ones. And we have capability of flying 4 experiments. This is a picture of the Kursk Experiment. I don't think I really need to go through this, but if anybody wants to go through it, we can. But this is the diagram of the whole system. The big thing we had was that there's an SDX here, and it's all controlled by the main computer, the IHU. And essentially what we do is we have a transmitter and a receiver, and the transmitter takes a 10.7 megahertz signal and transpons that up to the 2-meter transmitter signal frequency, and then we have the receiver. Its output is on 10.7, and what we do is we just inject signals anywhere in the passband, wherever we want them. This really shows the cabling diagram, where they have the main computer, the IHU, and then we have the solar panels, each one connected to a maximum power point converter. These are the cameras, or these are the experiments, and the cameras are connected here too. This is another picture of the inside. It was really great being able to just peel off the panels and work on it. That made it so much easier. This is the band plan. It's a very simple system. If you're using it as a transponder, you come in on 435.7 megahertz, and it comes right back out at 145.922. It's a linear transponder. We also have the FM at 145.95. That's what they're digipeating right now, or what they're repeating with that D700 right now. So they take this signal and retransmit it. The BPSK is at 145.92, and I have, let's see, this is what the signal looks like on a DSP, and I wanted to play a little sound for you. Does it take 2 hits or what?
2 clicks, yeah.
Maybe it takes more than that.
This one is not working.
Yeah, I can play that. But anyhow, on the FM, we have the voice ID, voice greetings, and slow scan video. And then we have another carrier, CWID. And then we have the experiment data, which comes down on the telemetry system. Let's see if we can play it here. There must be a difference between the Mac and the PC. Yes. We have voice greetings of 24 different greetings. A lot of them are in Russian, and we have several in English. We have Spanish, Russian, French. All these you can hear if you listen to the satellite. What we can do is play a little, just play that. This is one of the slow scan. Anyhow, we'll play it at the end here. We have 4 cameras. It randomly selects these cameras. If there's video on it, it'll select it. It won't transmit a black picture. So it's we tried to make it efficient. This is the Russian battery. Was never. The Russians ran it on this battery, ran the battery down. That's why they weren't able to do the original planned operation in April. This is a battery with cover on it. And here we are transporting it. This is my Suburban. The general purpose transporter. A little closer look. This is the 2 of them where we're taking these to shipping. This is the shipping facility. It's showing the 2 satellites. Packaging. This is in Moscow. And there we are packaging up, getting ready to ship it up on the Progress. They claim that they're instructed to take all these stickers on because, off because that messes up the thermal characteristics. But you know, the Russians, they put those on there for publicity purposes. Here they are loading it into the Progress, inside the Progress, and this is back up on the ISS. And hopefully they'll be taking it out Wednesday. And let's see if this plays.
Did you copy the file?
Yeah, it's in there. It's in the folder.
It's in the folder, so.
Let me let's see, how do we find that? Okay, play that one first. Okay, now let's play the other one. And this is one here that was recorded over Hawaii this morning.
Hi, this is AMSAT-1 amateur radio satellite RS-01S. En 2011, c'est l'opération comptant que le premier voyage de l'homme dans l'espace a été effectué. Nous, étudiants de divers pays du monde, selon tous ceux qui nous écoutent en ce moment, c'est l'équipage de l'appareil Radio 4.2, radio.
That's what they'll sound like. So thanks for your time. I'm glad I was able to show this to you. And we now have a new spacecraft ready to be put into orbit.